Alright, ladies and gentlemen, welcome to Forces 2, Lesson 5, Part 2. How does energy transfer from kinetic energy to potential energy? We're going to be looking at seeing how energy changes from kinetic, which is moving energy, to potential, and that is stored energy due to its state or position. What we're going to be looking at is how things transfer from potential to kinetic energy. So take this example from the yo-yo. As you let it go, it's falling down to the ground, but as it's on the farthest point, it's spinning and then rotates back up. Well, as it's going down, it's increasing in kinetic energy. So as it's dropping out, it's increasing in kinetic, but due to its position, it's actually increasing in, it's slightly decreasing in potential, but it still has potential energy because it is still off of the ground. And until it reaches the very bottom of the yo-yo, it is going to continue to have potential energy even though it is going down. So it's basically a transition. When you see things in motion, things are transitioning from kinetic energy to potential, but it might still have one or the other. Let's take a look at this example with the baseball. As it's going up, it is decreasing in its kinetic energy because the gravity is pulling it down, but it's also increasing in potential, which means it has a greater potential that as it falls, as we see later, it will have more energy. So the higher up something goes with this baseball, the more potential it will have, but there will be a loss of kinetic, even if it's still moving. But as it's falling down, the potential energy has reached its maximum at the very top of the throw. And that's due to, again, potential is it's the potential to have energy due to its position. And so as it's falling, we see potential decreasing, but kinetic is increasing. And we see that evidence as the ball is going downward. We're seeing it getting faster and it's accelerating. And so that evidence tells us that the kinetic energy is going up. So if things accelerate, that means we have an increased kinetic energy. But if they're decelerating, we are seeing deceleration. We're seeing an increase in potential energy, whereas kinetic goes down. Okay? And here we're seeing potential going down. So as things accelerate in free fall, kinetic's going up, potential's going down, but when things slow down, where we saw with the baseball going up, it's going to slow down as it goes higher up in the air because of the force of gravity. Our potential's going up because of how high it is, but our kinetic energy is going down. This might help us see it a little bit more clearly. At the very top of the hill, it has the most kinetic or potential energy it will have, which means when it moves, it's going to have an increased kinetic energy, but as it goes down, it still has at each of these levels, because it still has room to fall, it still has potential, but because it's going closer to the bottom of the slope, its potential is going down as it falls. And so at the very minimum here, at this point here, I'm going to draw it in dark greenish blue. This is where between the very top and the very bottom of our slope, we will have kinetic and potential equal at that midpoint. Okay, because there's still potential to increase speed, but it also reached about the same point where kinetic and potential will be equal. So if I were to look at something and I were to try to figure out, where is kinetic equal, where is potential going up, where is potential going down. Like this problem here with the skateboard, I'm going to be looking at here, trying to figure out where kinetic and potential fit. And so at the very top, where we see him going down, back down, that is when our potential is going to be at its highest, because it's not going to go any higher, and it's starting to fall down. And as he falls down, he's accelerating, and so his kinetic energy is increasing. But at the midpoint, we are seeing, at the midpoint between the fall and the top of the jump and the bottom of the half pipe, they're about equal. And at the very bottom of this, we see potential being the highest, or kinetic being at the highest point, which means that's the fastest he's going, or he will ever go, and the potential is at the lowest. So at the bottom of the hill, it's going to be the highest kinetic and the lowest potential. But as he's going back up, notice what's happening. We're starting to decelerate, which means kinetic energy is going down, and then potential energy is going up, because he's increasing his height, that when he falls back down, we are going to see him start to accelerate again. Okay, and so that would be how kinetic energy transfers from potential. It is a gradual transfer and handing off of kinetic to potential. It's not okay, it's stopped, so now it's potential, but now it's moving, so it's kinetic. And so I hope that generally helps you out with understanding kinetic and potential energy.